right, solving triangles. So we're going to be solving triangles first using the law of sine. So the most important thing before you solve a triangle is you must double check that your calculator is in degree mode. We don't usually give angles in typical triangles in radians in this scenario, so you do need to check that mode. If you're in radians, it will be wrong, so make sure you're in degrees. All right, so here's your law of sines. Basically, for any triangle, the nice thing is it doesn't have to be a right triangle. The ratio of the side opposite an angle to the sine of that angle is the same throughout the triangle. So this is called law of sines. All right, so we're going to go ahead and get started with the examples. Again, degree mode or this will not work. So solve triangle ABC if A is 36 degrees, B is 49 degrees, and little a equals 8. Remember, capital letters represent angles, lowercase letters represent sides opposite angles. So solving the triangle means find everything that's missing. So I'm going to go ahead and draw a picture. So here's my triangle. Which is which, it doesn't matter, just make sure you label it. So I'm going to call that A, I'm going to call that B, and I'm going to call that C. All right, so we were given angle A is 36 degrees, angle B is 49 degrees, and side A is 8. So side A is opposite angle A. All right, so if I'm looking at this triangle, I'm going to go ahead and find angle C first. The order you find them in, it's going to vary depending on what you're given. What you got to remember about a triangle is the sum of the angles in a triangle is 180 degrees. So that means that angle C is going to be 180 degrees minus the sum of the other two, A and B. So angle C is 180 minus A was given as 36 and B was given as 49. So then we go to our little handy dandy calculator and we do some math. So I'm not going to bring the calculator up on the screen right now. I think we're good with you doing this math without seeing the calculator. So we get that angle C is 95 degrees. Okay. All right, so I have angle C, so now I've got to find the missing sides. I've got to find side B and I've got to find side C. So I'll start with side B. So in order to find it, I need a complete ratio. So I've got angle A and side A. So we're looking for side B. So I'm going to find B first. So I know that the ratio of side A to the sine of angle A has to be equal to the ratio of side B to the sine of angle B. So I can plug in what I know. So side A is 8. Angle A is 36, so sine of 36. Side B is what we're missing. Sine angle B, 49. Again, make sure you are in degree mode or these will come out wrong. So if we're solving for B, I like to solve for B before I do any math because we don't want any rounding error. We're going to multiply by sine of 49 on both sides. So side B is going to be 8 times the sine of 49 degrees, all divided by the sine of 36 degrees. So we would type this into our calculator as is. So I'm going to get my fraction template. Make sure you're in degree mode. We want to do 8 times the sine of 49. And then in the denominator, we're going to do the sine of 36. So we get B equals, and it says to 3 decimal places, 10.272. So again, make sure you answer correctly online. Sometimes it's going to say 4, sometimes it says 1. Don't get it wrong because you rounded to the wrong number of decimal places. And now I need side C. That's crooked. So we're going to find C now. So side C, I'm going to use the same ratio A. So the side A, the ratio of side A to the sine of angle A is the same as the ratio of side C to the sine of angle C. All right, so A is 8, or I guess side A is 8. Angle A is 36 equals side C is what's missing. the sine of angle C. Angle C we just found was 95. And then we do the same thing. We're going to multiply by sine of 95 to get the C by itself. So C is going to be 8 times the sine of 95 degrees divided by sine of 36 degrees. So we go to our handy dandy calculator and we type this one in. So we've got the sine of 95 times 8 over the sine of 36, 13.55, and then rounding to 3 would be 559. So we were given 3 pieces, we had to find 3 pieces. All right, example 2, solve triangle ABC if A is 50, C is 33.5, and B is 76. I'm going to draw my triangle. All right, A. I'm just going to do a little different orientation. We'll go A, we'll go B, and we'll go C. All right, angle A is 50. Angle C is 33.5. Side B, 76. So the 76 goes opposite angle B. All right. In this case, I'm missing one angle, so I want to go ahead and find that angle first. So remember, the sum of the angles in a triangle is 180. So angle B is going to be equal to 180 minus the sum of the two that were given, A and C. So angle B is 180 minus the sum of 50 and 33.5. So 180 minus 50 plus 33.5 in parentheses gives us 96.5. So angle B is 96.5 degrees. All right, so I got all my angles, now I need to find my sides. So sides, I'm missing side A, so I'm going to find side A first. Actually, you know what, back up here, I should have used lowercase letters there since we weren't looking for angles. So here, let me do B and C. All right, anyways, back to this one. All right, side A. All right, side A, I need a complete ratio, which is going to be angle B and side B. So I know that side B to the sine of angle B has to be the same ratio as side A to the sine of angle A. So then we go plug in. Side B is 76. Angle B is what we just found, 96.5. And then side A is what we're looking for over the sine of angle A, which was 50 degrees. So side A is going to be 76 times the sine of 50 degrees divided by sine 96.5 degrees. So then we go calculator that. So we've got 76 times sine of 50 divided by sine of 96.5, which gives us 58.596. All right, the other side that we were missing was side C. So same ratio, side B, the ratio of side B to the sine of angle B equals the ratio of side C to the sine of angle C. So side B is 76, we're using the same ratio we did to find A, over sine 96.5 equals side C, which we're missing, over the sine of angle C, and angle C is 33.5. So same algebra, C is going to be 76 times the sine of 33.5 over the sine of 96.5. So once again, we carefully push some buttons. So let's 76 times sine of 33.5 in the numerator, sine of 96.5 in the denominator, which gives us side C as 42.219. All right, so in each case we solved where we were given two angles and a side, we were given two angles and the side in between. So those were the two cases we've looked at thus far. The third case is a little bit of a pain in the butt. So this case results in either none, one, or two triangles. So here's why you need to be careful. So make sure you read over this, look at the images to kind of show you how things are broken up. What we're going to be doing is comparing what's called a pivot leg to an adjacent leg. So again, the only one you've got to be very, very careful about is when you're given two sides and the non-included angle between them. If it's an included angle, you're fine. If it's a non-included angle, we've got a problem. So I've got it written several different ways, the visuals versus the tables. The tables is what's going to help you probably the most in figuring this out, and the key is making sure that you can identify your pivot leg versus the adjacent leg, because you've got to know which one it is you're looking at to compare them correctly. So pivot leg versus adjacent leg is what we're going to have to pay attention to. All right. And then in a case of having two triangles, we need to know which angle it is we need to find first. So, at example 3, determine the number of triangles formed based on the given information. So it does not say to solve them, it just says determine the number of triangles that are created. Okay. So we're not solving, we're just figuring out how many triangles are. Once we've done that for a couple of times, then we'll go back to solving our triangles. But first we just need some practice figuring out, do we have none, one, or two? All right, so first one, draw a picture. So we've got side A is 4, side B is 3, and angle B is 122 degrees. So we want to draw our picture. All right, notice angle B is 122, so I do want to make mine look a little bit accurate on my drawing. That is an obtuse angle. Oops, it didn't quite cooperate that much. Let's see, there we go. So because B is an obtuse angle, I'm going to make sure I put B here. The other two, A and C, I'm not too worried about, but I do want to make sure I have it labeled correctly. All right, side A is 4, side B is 3, and angle B is 122. So we confirm that is the side angle case. So it's two sides and the unincluded angle. So when we draw this, we need to identify the pivot and we need to identify the adjacent. So the adjacent leg is the one next to the angle. The pivot leg is the one opposite the angle. That is the one, if there are two triangles, it's the one that's allowed to swing to create them. Okay. So if we look at our table, we need to, this is our obtuse case. So back up here, I've got a table for you. Way back up here. We are looking at the obtuse case. Okay. So we either have one triangle or we have none. So what we need to do is compare the pivot to the adjacent leg. If the pivot is bigger than the adjacent, there is one triangle. If the pivot is less than or equal to the adjacent, that means it's broken. We can't complete the triangle because the sides aren't the right lengths. So we're looking at our pivot. Let me go back to blue. So our pivot is 3. Our adjacent, actually I'll put it on the outside, oops, is 4. So in order to have a triangle here, the pivot must be bigger than the adjacent. So if I look at this, in order to have a triangle, I need the pivot to be bigger than the adjacent. Clearly 3 is not bigger than 4, so that means there is no triangle, it's broken. So we can't solve it if it's broken. So just no triangle. Right? Case number 2. All right, we are given C is 56, A is 11, and C is 11.5. So picture. All right, so C is 56. So since that's acute, I'm going to call that C. I don't know the other two, which one needs to be which, so we're just going to go with this. All right, angle C is 56 degrees. Side A is 11, and side C, 11.5. All right, so it's not the obtuse case, this is our acute case, so we need to label, here is our pivot, here is our adjacent. So this is an acute case, so what we need to do is we need to find the height, so the one you drop to when you're looking for a height, let me get some dashed lines in here, there we go, and you want to drop it from the angle between the given sides. So the height we're going to be looking at to compare to see how many triangles we have is going to be this height right here. So I'm trying to, that's not a color I want. What color? I'm going to make you purple as well. So this, whoa, that's a dark dot. Hang on. Let's try that again. Okay. This is the height we need to calculate. So again, you can read about the height up there. So it's a right triangle with a height. So that means the sine of 56 is equal to the opposite over the hypotenuse. Well, that opposite is h. So if we look at that mathematically, our height, our sine of angle 56 equals h over the hypotenuse, which based on our height we drew 11. So our height is 11 times the sine of 56 degrees. So let's go get an estimate of our height here. 11 times the sine of 56 gives us a height of 9.119-ish. Okay, you don't have to go that far out in decimals in this case. We just have to compare them. All right, so what we want to do is look at how that compares to our table above. So I'm going to compare the height with the pivot and the adjacent. So our height, h, let's see, we'll do this over here on the side. So h is, if I look at 9.1, h is less than the adjacent leg, and h is less than the pivot leg. Okay, so because the height is less than that, and then we have our pivot, which is less than, greater than, get it right in a minute. The adjacent, we're going to have one triangle. So again, if you go to your table back up here at the top, this is not the obtuse case, this is the acute. So our pivot is greater than the adjacent and the pivot is greater than the height. That means we have one triangle. So one triangle. All right, I'll zoom out on that one so you can see it all at once. All right, next one. Actually, I need to scoochy. There we go. And then we'll separate. Separate. All right, C. All right, B is 12, A is 7, and A is 36. I think we got quite a few examples in here. Just for time's sake, so that the video is not so long, I'm going to skip over. Let's skip over. Well, no, let's go ahead and do B. I want to do B because A was different. It was acute. This one, or obtuse, this one is acute. So never mind, scratch that. All right, picture. Here's my triangle. So I'm going to call you A, you B, and you C. All right, A is 36, side B 12, side A 7. All right, so we need to compare. So pivot versus, it's the acute case, so we need to know which is which. You are the pivot. You are the adjacent. So the height we drop in comes from the angle between the given sides. So this is going to be the height we're going to calculate. That height is this hypotenuse, which is the adjacent side, 12, times the sine of the given angle, 36. So our height is, let's see, 12 times the sine of 36, 7.053. All right, so we need to compare our height. Our height and our pivot, our height is bigger, so our pivot's smaller, so our pivot is less than our height, and our pivot is less than the adjacent. When the pivot is smaller than both of those two things, there's no triangle. It's broken. We can't complete the triangle. So there's no triangle here. All right, D. All right, we'll go with you, your B, your A, which means your C. All right, A, side A, 7, side B, 6, angle B, 45. All right, height we're looking for comes in between the given sides. So here is our height that we need to figure out. Our height is 7 times the sine of 45 degrees. I guess it would help if I labeled pivot, adjacent. That way we know which is which. All right, so 7 times the sine of 45, 4.949. Actually, here I'll go 4.50 if I'm going to round them to 3. All right, so we have our height, 4.9, which looks like the smallest. Then in the middle is our pivot. And then above that is the adjacent. So when the pivot is slammed between the height as the smallest and the adjacent as the largest, this is the case that's going to create those two triangles, because what's going to happen is that pivot side can swing and create an obtuse triangle and an acute triangle. So we have two triangles in this case. The key when you do run into that two triangle situation, the key for solving this triangle is you need to find the unincluded angle first. So if we look at our picture here, the unincluded angle means the angle that's missing, that isn't between the given sides, would be angle A. So we would want to, if we were solving, find A first, and that's what we would use for our first triangle, and then for the second option triangle, I call it A sub 2. Angle A sub 2 is the supplement of A sub 1. So angle A sub 2 would be 180 degrees minus that first A that we found, and then that would be your starting point to finish the other triangle as well. All right. So I think we've done several examples here. So I will fill out E and F on the completed notes if you want to look at those, but I think 4 determining the number of triangles is plenty for the videos, just to shorten it just a little bit. So let's go ahead and jump down to the next example where we're solving the triangle. Okay. All right. So example 4, solve triangle ABC if angle A is 43.1, side A is 186.2, and side B is 248.6. So here's my triangle. I'm going to go A, I'm going to go B, and I'm going to go C. All right, angle A, 43.1, 0.1 degrees. Side A, 186.2. Side B, 248.6. All right. This is that side angle, so we need adjacent versus pivot. You are the pivot. This is the adjacent, so the height comes in from that angle between. So this is the height we need to calculate to figure out how many triangles we have. All right, height is going to be 248.6 times the sine of that angle, 43.1. So we've got 248.6 times the sine of 43.1, which gives us a height of 169.862-ish. All right, so if we look at our side lengths, my height looks like the smallest. So my height is less than, it's 186. Then my pivot is in the middle. And then my adjacent is the largest. So when the pivot is above the height but below the adjacent, we have two triangles to solve. So we've got to make sure we keep them organized so we know which triangle is which. All right, the key to solving that two triangle scenario is solving for the unincluded angle first. So we're going to use law of sines to solve for the unincluded angle, which would be angle B. So all my first triangle is going to be subscripts of 1. So this is going to be triangle 1. So angle, I'm going to call it B sub 1 is what we want to find first. So remember, law of sines can be turned upside down as well. So the sine of angle B sub 1 over side B is the same as the sine of angle A. Remember, angle A is complete, and side A, which is also given. So angle A and side A are not changing because they're already given up there. All right, so sine of angle B sub 1 over side B, which is 248.6, has to be equal to the sine of angle A, and A was 43.1, over side A, which is something, 186.2. All right, so get sine by itself first. So we're going to multiply both sides by the 248.6. So that's going to give us sine B sub 1 equals 248.6 times the sine of that angle, 43.1 degrees, all over 186.2. And then remember, to remove sine, we use inverse sine. So we got to get angle B out of there. So our angle B is going to be the inverse sine of this lovely fraction here. So I'm going to be lazy. Copy paste, because that's the beauty of an iPad. So, whoops. All right, so very, very carefully we're going to type this into our calculator. Make sure it looks exactly as written. So here, I'll bring the, let's see, I'll bring the calculator up for you, maybe. All right, so that's not what I wanted it to do. I wanted it to there we go. Okay. All right, so clear. So I'm going to go second. Actually, I'm going to check my mode first. Oh, it's being a pain in the butt. It's not wanting to work. All right, so I'm going to hit my mode first. Oh, I'm in radians. I'll do it wrong. That would be a problem. Got to be in degrees. All right, I'm in degrees. So second sine alpha y equals 248.6 times sine 43.1. Get those parentheses closed. Denominator 186.2. Out of it, close it, enter. So our first angle B for our first triangle is going to be 65.81, if we round to 3, 9 degrees. All right, before I finish triangle 1, because I don't want to forget which angle is which, I immediately want to go find the angle B that is associated with triangle 2. Okay. So I'm going to do triangle 2 in, let's go with another color. Let's go with dark blue. All right, triangle 2. Well, actually, I'm going to go way over here because I still got to find other stuff. All right, triangle 2, I call it B sub 2. So all my subscripts with 2's will be the second triangle. B sub 2 is the supplement of that angle we just found. So if I take 180 degrees and subtract B sub 1 from it, which we just found in the calculator right there, that will give us the starting point for triangle 2. So I'm going to do 180 minus, and then I'm going to do second answer to pull that number down for me. So there is my angle B sub 2, 114.181 degrees. All right, so I've got my starting point for triangle 2. So now I can go back and finish my triangle 1 out. So what was missing from triangle 1? We are missing angle C. So I'm going to go find angle C first, and then we'll go find side C. All right, angle C, which again, I'm going to call it C1 because all of these values will be different once we use the new angle B. Angle C1 is going to be, because it's the only angle left, 180 degrees minus the sum of the two angles we have, which is A plus B1. So angle C1 is going to be 180 degrees minus A, which was 43.1, plus B, which again, be careful, don't get them mixed up in the calculator, the 65.819 value that's sitting in that calculator right there. So I'm going to do 180 minus the sum of 43.1 plus, and then I'm going to go up and get this number, which is going to be enough decimals that it's not going to have a rounding error. So our angle C is 71.081 degrees. All right, so I've got side B1, I've got angle C1. Now we need side C. So law of sines. Side C1 is going to be the ratio between its angle. Sine of angle C1 is equal to side A over sine of angle A. Okay. So C1 is what's missing. So C1 is going to equal side A times the sine of angle C over, that's a crooked division bar, the sine of angle A. Now, you don't have to plug those numbers in here if you don't want to. Everything's labeled in this problem. That's good enough work for me. So I'm going to go to my calculator. I'm going to go alpha y equals. So side A is 186.2 times the sine of angle C, which is that 71.08 mess we just found here. So I'm going to go get that, divided by the sine of angle A, which is 43.1. So our side C1, don't you love the two triangles? 257.790 if we're going to 3 decimal places. So there is our other missing side. Okay. It's a nitpicky when you got 2 triangles. All right. So back to triangle 2. So triangle 2, we've already found B sub 2, so I'm going to do the same process to find C sub 2 and, or I guess angle C sub 2 and side C sub 2. It's just, we're going to have a different ratio in there. So angle C sub 2 is the only one we're missing at this point. So angle C sub 2 is going to be 180 degrees minus the sum of the angle A, which is fixed, plus the angle B sub 2, which we just found earlier, right? So again, this is enough work for me because we do have all the values saved. So we've got our 180 minus the sum of angle A, which I believe is 43.1. Yes, 43.1, plus angle B sub 2, which is that, I'm going to go up and get it in my calculator just because I don't want rounding error and I completely forgot to store it. Oh, no, it's not going to let me go up and get it. Okay. Well, we'll just type it in. 114.181. That's close enough because homework, it's going to have you rounding differently, so that's going to be accurate enough. All right, so our second angle 2 is going to be 22.719. All right, so then side C sub 2, so we got our angle B2, we've got our angle C2. Now side C sub 2, the ratio of it to the sine of this angle we just found is the same, and I'm going to stick with A because we already know that. Side A over the sine of angle A. So if we solve for C sub 2, we get that C sub 2 equals side A times the sine of the angle we just found, C2, over the sine of angle A. And we have all of these values in here so we can go to our calculator and get them typed in. So I'm going to get my fraction template first. Side A, if we go back and look at our triangle, back over here, side A is 186.2 times sine of angle C2, which is this angle we just found here, so I'm just going to go enter it in, divided by sine of angle A, and angle A was 43.1. And finally, we have our last missing side. So make sure you keep this organized. Triangle 1 versus triangle 2. You don't want to get this information mixed up because the 3 answers go together with triangle 1 and then the other 3 answers go together with triangle 2. All right. Last one. So a little application here. So for this one, it says to measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance of 3,000 feet apart at the same elevation. So what we want to do is get a picture drawn. So we've got a mountain. Here's my mountain. Here's my ground. So it says he takes 2 sightings at a peak, a distance 3,000 feet apart. So 2 sightings at the peak. Let's go here. So that's going to be the peak. Sighting number 1. Sighting number 2. It says those 2 sightings are 3,000 feet apart. So this distance right here is 3,000. Let's see. The first observation results in an angle of elevation of 48. The second results in an angle of elevation of 35. So remember, the closer you are, the further you've got to look up. So what that means is this angle here is the 48-degree angle because it's larger. The second one is the 35-degree angle because it's further away. All right, if the transit he used to measure the angle is 5 feet tall, so a transit's like if you see this little surveyors on the sides of the roads with the little tripods, that's a transit. So what that means is these 2 survey points, they're an extra 5 feet off the ground. What is the height of the mountain? So height of the mountain is what we are looking for. So the height of the mountain is going to be this distance right here, h, but remember, it's 5 feet off the ground, so we're going to have to add 5 to it. So I'm going to go ahead and just write h plus 5. All right. We got a lot of information going on. So what we need to do is find some information. So as far as what to find first, there's a lot of different ways you could do this, but if I'm looking at this problem right here, if I can find, remember a height is measured perpendicularly, so right here. So if I can find the length of this side right here, that should allow us to find our height because we can then use law of sines because we will have a complete ratio. Law of sines works with right angles, so we will have a complete ratio right here, so then we can use that one to find it. And one other thing, I do want to, just so it doesn't look so confusing, we just need to remember to add 5 at the end to our height. So that way, since I already put the 5s over there, I'm gonna just go ahead and put it here as well. All right, so I'm gonna focus on this triangle right here. So I only have one angle. However, remember that 48 and the other side of it must be supplementary. So if I take 180, here, let me clear all that out since we don't need it. 180 minus 48, I know the other side of that angle. So right here we have a 132-degree angle. So that gives me 2 angles in the triangle, which means I can find the third angle. So this angle here is going to be 180 minus the sum of the 35 and 32. So 180 minus the sum of that 35-degree angle and that 132-degree angle, because we just found them. So 180 minus 35 plus 132. So we have a 13-degree angle right here. So I'm going to go label it 13 degrees. All right, so I have all 3 angles and I have the side between 2 of those angles, so I can use law of sines to find, I'm going to find that side there. I'm just going to call it x. So side x, the ratio of side x to the sine of the angle opposite that side, which is the 35-degree angle, has to be the same as the side 3000 and the sine of the angle opposite it, which is that 13-degree angle. So that means side x, missed my x, is going to be 3000 times sine 35 over sine 13. So in our little handy dandy calculator, make alpha y equals, I want my fraction template, 3,000 times sine 35 over sine 13 tells us that x is a rather large number because we are dealing with a mountain. 7,649.349 what are we in? Feet? Feet. So not an answer we need, but as far as what we're asked to find, but we've got to find this first so that we can find something else. So I don't want to have to remember this number, so I'm going to go into my calculator and I'm going to store this as X because I called it X. So I'm going to hit my STO button, remember, right above on. It will pull that answer down and it will save it as my X key. That way I don't have to worry about this number. I can just use it. So now I'm focusing on triangle number 2, which is this one right here. So here's triangle number 2. So I have a complete ratio because I have X and I have a 90-degree angle. Law of sines works no matter whether we're dealing with right triangles or oblique triangles. So I know that to find H, side H, the ratio of side H to the angle opposite it, which is that 48-degree angle. So the ratio of side H to the sine of the angle opposite it, which is 48 degrees, has to be equal to the ratio of side X to the sine of the angle opposite side X, which is 90. So if we manipulate this, we get that our height is side X times the sine of 48 degrees over sine of 90 degrees. So I can type it into my calculator just like this. So alpha y equals X times sine 48 over sine 90. And we get 5,684.57-ish. Just be careful, remember. That transit was 5 feet tall, so the height of the mountain is this plus 5. So then I'm going to go add 5 onto it. So our height of our mountain I'm out of room right there, is 5,000, how are we supposed to answer? It doesn't say, we're gonna go nearest foot. We don't really measure that kind of distance in decimals. 5,690, because the 0.5 would round it up, feet. So I don't know if that's a tall mountain or not. All right, so key there is a picture. Nice thing is most of the word problems in the text will already have the picture drawn for you, because that's usually the hardest part. So I wanted to make sure we worked an example where you did have to draw the picture on your own. All right, last thing. I know, it's a lot. Areas of a triangle. So this is going to be how you find the area of a triangle when you are given two sides and the included angle. We're not going to get complicated when it's given other scenarios. So just two sides and the included angle, that's going to be the formula you use for an area. So it says find the area, example 6, find the area of a triangle if it has legs of length 24 and 10 and the included angle measure is 62. So if you wanted to draw a picture, you could. So here's my triangle. All right, it's got legs of 24 and 10, and the included angle is 62 degrees. So I'm going to call this bottom angle right here my 62-degree angle. Legs are 24 meters and 10 meters. Just make sure you put them on the sides between the angle. So the area of this triangle is going to be, if we look at our area formula, 1/2 the product of the legs times the sine of the angle between them. So the product of the legs, or I guess 1/2 first. Product of the legs would be 10 times 24 times the sine of the angle between them, which was 62 degrees. So in our calculator, we're going to go 0.5 times 24 times 10 times the sine of 62. So our area of our triangle is 105 point, I like 3 decimals, so that's what I'm going with, 954. Yeah, I was given units, so I want to make sure I use my units, meters squared. All right, so that's the end of this section. I know this was a long note, but I wanted to make sure you had a variety of examples to look at.